Good morning, good afternoon, and good evening to all of you who've just joined us. My name is John. I am the host for track two for today. We are very fortunate today to have Amol, who is a hybrid cloud architect from Google, who is actually chairing this session for track two today. And the key topics that Amol will be taking us through on this workshop, it's called Achieving Ultimate Infrastructure Automation with Pulumi and Python. Wow, what a great topic that we have today. Hi, Amol. How are you doing today?
John, I'm good. What about you?
I'm good as well. Thank you, Amol, for joining us. I'm going to hand over the session to you
Sure.
to take us through the workshop. I hope our participants are ready to go to learn more from you in that sense. Over to you.
Great. All right. Is my screen visible? Great. All right. Very good morning and a warm welcome to all present. Thanks for joining this workshop on achieving ultimate infrastructure automation using Pulumi and Python. I am Anmol Krishan Sachdeva, and today I'm going to have you get a deep dive of how you can achieve automation using some of the most commonly used strategies with Pulumi. We are going to see a couple of examples as well because this is going to be a workshop. So we'll have a couple of hands-on stuff as well supported throughout. A bit of background about myself before we move ahead. So I'm an international tech speaker and a distinguished guest lecturer. Have helped organize a couple of conferences across the globe like EuroPython, GeoPython, and a couple of PyCons. And I like mentoring people, and that's where I like also speaking a lot about technology in varied domains. So that's about me. If you're interested in connecting with me, at the top right, you'll see a QR code. You can just scan that and we can connect over LinkedIn or Twitter. So just a disclaimer before I get to the session. The content and views presented during the workshop are my own and should not be associated with any organizations or professional bodies that I'm part of. And let's get to the agenda of this particular workshop. So first we'll go through a brief introduction of what infrastructure as code is, how it got evolved, and uh, what are the differences between imperative and declarative configurations. And ultimately, we are then going to get introduced to the world of Terraform and Pulumi, and we are going to see how Pulumi contrasts with Terraform, what all things Pulumi excels at, and for what all scenarios you would be using Pulumi over Terraform, and so on. And then we are going to have an architectural dive into the way the components of Pulumi are arranged and what all functionalities each component possesses. Then we are going to see a couple of concepts related to Pulumi, like project stacks, and then we are going to have a brief introduction to what component resources are. I am not going to extensively cover advanced topics as of this session because this itself will be getting a bit overwhelming for the participants who will be having this taken for the first time. So I'll keep it balanced across. And then we are going to see one example of how we can have some code written in, let's say, Pulumi YAML converted to Pulumi Python. We are going to see how we can have a Terraform code converted to Pulumi, and that too in specific programming language of our choice. That's Python for this particular session. And towards the end, I'll just give a small demonstration of the newly launched feature of Pulumi, that is Pulumi AI, which helps you generate automation code on the fly. So the concept of infrastructure as code is not new. It essentially roots back to around 3 to 4 decades ago when tools like Make, many of you would have already worked on that probably, and PXC boot, etc. They existed, and those were the times when people treated these tools for performing some automation in terms of configuration. And this is where the emergence or advent of infrastructure as code, or let's say the roots of infrastructure as code were laid. And as in when we had technological revolutions happening, we actually had more and more infrastructure and compute requirements growing. This is where people started to build some domain specific languages which abstracted how different hardwares were to be interacted with. So if you were to have a fleet of, let's say, machines running Unix operating system, different distros and all, you could still have a common domain specific language also called as DSL, which could front all of those and then have the configuration performed for those machines, regardless of which distro they are part of, right? So this is where tools started becoming mature, and then we had the cloud evolution. And with that cloud evolution and cloud computing coming in picture, we had more and more infrastructure requirements, like having resources deployed in cloud, having managed resources of the kind of platform as a service or SaaS or IaaS getting rolled out using infrastructure as code. So this is where tools like Puppet, Chef, Ansible came into picture, and then those were not infrastructure as code utilities. Those were more focused on host configurations and configuration management for host related, let's say, management. So this is when people got into a lot of these tools. They started exercising, and these tools were helping scale well with the requirements that they had. But then the containerization revolution happened, and people started to utilize Docker, Kubernetes, and the year when Kubernetes was launched, there was another project that was launched that was Terraform. And Terraform essentially brought its own DSL or domain specific language named HashiCorp language. And this is where things started making more sense, and we started to get evolve in the field of infrastructure as code, because now it was not only that we were able to have some uh, handful of machines orchestrated, but we were able to have a lot of managed resources on cloud handled, and it was not specific to only one cloud. It was able to cover for multiple cloud providers. So Terraform essentially took birth, and then the IAC stuff started. However, with respect to Terraform, there are a couple of caveats, and one of the challenges to start with is around Terraform is more suited for IT operational tasks and workflows. What if someone doesn't want to utilize a domain specific language, or one doesn't need to really exercise the logic in a very plain manner? Some more complex logic is required, like putting some advanced conditionals. Now, these days, with the latest Terraform versions, there are a good number of preconditions, post-conditions, validations, and life cycle changes that are possible, the configurations that are possible. But then still, there is a good room for bridging, and there are a lot of features around using sophisticated looping mechanisms, using conditionals, using functions, so that you can make your code modular enough and you can reutilize your code. And uh, what if you were to have the power of creating, let's say, classes, so that you can lay out a blueprint, so that if you were to, let's say, just spin a Kubernetes cluster, regardless of which platform or provider you would want to deploy that to, be it Amazon EKS, be it Azure AKS, be it Google GKE, be it let's say IBM specific Kubernetes cluster. So what if you were to have a common class with a blueprint, which regardless of the provider had some implementation in form of constructors, in some form of coherent resources, which just worked on the values that were provided, and regardless of the provider, they used to, let's say, or they are capable of going ahead and spinning the Kubernetes clusters. So that is where there comes a need for having a kind of utility which gives us more power, more control over code. And this is where tools like Pulumi and cloud development kits, or CDKs as we call them, were born. And most of the requirements that I talked about were addressed. Now, there is something which is happening, as in when we are kind of getting into the space, there was another thing which started, wherein people started to coin a term around not infrastructure as code, but infrastructure from code, wherein people started to tell that managing so many providers could be a nightmare, and it is not optimal or feasible for people to know for which kind of application we should have which kind of infrastructure deployed. And that's where people started to think of infrastructure from code, and tools like amped or eventual came into existence, like, and there are more tools like Bing and all, which came into existence, and they are still in very nascent stage, not very mature. But the thing is, you don't really need to have infrastructure code defined separately, application code defined separately. You just write the application, have some libraries utilized for these utilities, and you essentially have the corresponding infrastructure provision for you. So that is infrastructure inspired from your code. So that's where infrastructure from code comes into picture. So that's the next thing in the IAC or IAF space, if or IFC space, if I have to call that. But the focus of our of our talk would be primarily Pulumi, which is infrastructure as code and not infrastructure from code. So probably that's another workshop that we may need to delve in future. So you probably would be surprised that Pulumi essentially supports a bunch of converters, and this is where we'll have a glimpse of these converters towards the end, and we'll have one converter for YAML scene. I'll have a hands-on, and I'll also share a small hands-on lab with you, which you can follow after the session if you are interested. And then we will have a conversion for Terraform to Pulumi done in the Python programming language. But then the thing that you need to understand is that Pulumi is enabling you to have code maintained in the supported general purpose programming languages like Golang, Python, C#, .NET, JavaScript, TypeScript. There are other markup languages like YAML and CUEQ, which is kind of a recent development. All of these languages and markup languages are supported, and this makes it very convenient for the people who want to go with an approach wherein they may want to exercise handling of infrastructure through code, literally code, not declarative or DSL way, but a code which is written in a programming language which is imperative in nature. But then ultimately you are having a blend of imperative configuration and declarative configuration in order to achieve your end state. So that's the beauty of this. So Pulumi is essentially both imperative and declarative. There is no one single thing, and we'll get to understand more about this once we start exploring the components from an architectural perspective. But yeah, we'll have these kind of things explored shortly. So code has a lot of advantages to add on what I essentially have already mentioned. So say now it's not just about writing blueprints. Now it's not just about writing loops or conditionals. It's also about understanding if the code that we have created can be packaged or can be turned into a library that can be used by us or by our, let's say, mates in the organization or anywhere else in open source, regardless of whether they are using Python as the language or whether they are using TypeScript with Pulumi. Now, how wonderful it would be that regardless of what the target language is, whether it's TypeScript, JavaScript, Python, Java, you have created a package or library in Python, and that library is reusable across the different programming languages that are supported by Pulumi. So this is where packaging and module creation is something that comes into picture, and Pulumi essentially has a support for this. So that's another advantage, and that's where the power of code is. And what if you get to understand that you can actually enjoy rich IDE support, because essentially you are going to have everything coded in form of your regular programming language, and the kind of formatters, linters, static quality, code check, utilities, pre-commit hooks, etc. Whatever you use to exercise for application development, all of those things can be exercised through your IDE, because these are regular programming languages and you are just writing your infrastructure code by reimagining it in form of a programming language and not a DSL. And what if you also were to get type checking, code smells, writing integration tests, unit tests? Now, some people will say that integration tests are also possible as part of Terraform. But then unit test is not something which Terraform supports. So you can actually have unit tests also written as part of Pulumi. And this is where it doesn't stop. It has a lot of things which it has to offer. And readability is one of the things. If you are coming from a background, not DevOps background, and you are not used to YAML, JSON, and handling configuration using such kind of languages, in that case, and you are coming from application or programming background, then you may be literally enticed to explore such kind of utility which gives you more control, and probably you can have code embedded in your application to create infrastructure. So what if you are creating an application, and then in that application code itself you have written some classes, or you have structured your code in a manner that you first have the infrastructure created, then you have your application run on top of the same infrastructure? Or what if I were to tell you that you create infrastructure? Let's say you create an AWS S3 bucket, and on that AWS S3 bucket, as and when the AWS S3 bucket is created, you have an AWS Lambda function getting executed because you have defined that as part of your infrastructure as code. So this is where you can have function serialization, or you can have Lambda execution done as part of Pulumi. So that is another feature of Pulumi, and what you get on top of existing stuff. So in nutshell, you are able to create, deploy, and manage a lot of resources using Pulumi's SDK. And this is where Pulumi is essentially offering more than 100 packages, or has support of more than 100 providers. And this is where when it gets compared to Terraform only has support for 35 providers officially. There are community providers and some kind of self-owned providers which people have gone ahead and committed, and that is where the list of providers really grow in Terraform. But the official providers for the official products that are there are about 35 providers in Terraform, which are which is a small number as compared to the support that Pulumi has. So in order to understand how Pulumi works, we'll just get to that. Pulumi is essentially offered in two flavors. One is the open source flavor, and the other one is essentially focused on making open source or extending open source with some kind of enterprise features, so that you can get a fully managed platform, and that is supported through UI and API. Now, the best part of it is that if you are an individual contributor, you can actually exercise all those things through a free account. If you are an organization, then only the enterprise thing applies to you, which means I can go ahead and I can have my Pulumi related experience for Pulumi Cloud also leveraged without any hassle. Then secret management is something which is pretty decent in Pulumi, and we'll get to see when we have it compared with Terraform. There is something called as remote state handling. So by default, Pulumi will store state in the Pulumi state that comes natively, and you can have the remote state handled in any backend like GCS or S3, very much like how Terraform supports. Certainly, like the number of backends and the type of backends may differ, but just to give you an idea, like the GCS buckets or S3 buckets both will be supported, and they will be support for more buckets as well, which you can check on the documentation. And then there is something called a stack configuration, which enables you to have different environments realized for your same, let's say, template or code. So very much it's like Terraform workspaces feature, if you have worked on Terraform workspaces, wherein you can have different, let's say, state in terms of variables, in terms of configuration that you want to apply against the same set of templates. So that's where you have stack configurations coming into picture. So I'll have a brief of stack covered shortly. So this is where let's get to understand, and let's get deeper into, or delve deeper into how really Pulumi works, and then I'll have this all linked to the architecture that I'm going to show shortly. So imperative configurations essentially are the ones wherein you need to have explicit instructions provided, and this is where you need to tell the system how to achieve some specific task. Whereas declarative configuration is where you essentially describe the outcome, and the system is smart enough to figure out on its own how to achieve or get to that particular outcome. So this is where people may think that, okay, Pulumi is providing support for programming languages, so the programming languages are essentially imperative for which the support is getting provided. So Pulumi should be imperative. Then some people will argue that ultimately it's infrastructure as code. We are defining some state that is getting achieved, so it should be declarative. It's not imperative, because we are just defining what we require, and then that's just in form of programming language. So it could be that it's declarative. So the answer is that it's both declarative and imperative. And when I go through the components, I'll just explain you why it's the behavior that I talked about. So just a quick discussion about the differences between Terraform and Pulumi. So Terraform essentially is supporting only one language, which is the DSL language. So that's where the support is limited. But already we have covered that Pulumi is supporting really rich set of general purpose programming languages, as well as markup languages like YAML and Q. And in terms of maturity, Pulumi is still growing. So there may be some documentation related, let's say, gaps, because the community is mid-size. But recently, Pulumi has seen good traction. So that's where we are seeing the number of contributions being made to the Pulumi project even growing. Now, certainly, with respect to community contributions that are there in the Terraform space, Pulumi is not there yet, but it's picking up. The things start getting interesting when we talk about how we have the support in terms of, let's say, cloud native nature. So this is where you have some in-cluster operators that are available, and some custom resource definitions that are available, which enables the GitOps journey with Pulumi really seamless. Whereas Terraform doesn't have such kind of support, and there are only APIs that you can use. So this makes the GitOps approach a bit difficult with Terraform. So for the people who are not familiar with GitOps approach is essentially where you treat your source code as the source of truth, and essentially you have the CD, not the CI portion, the CD portion covered through the GitOps strategy, wherein when you make commit, there is some pull-based mechanism which pulls from that Git repository, let's say, and then it applies the configuration to the target platform. So that's where you have the GitOps coming into picture, and there are tools for GitOps that are available, like Argo CD, Flux CD. So there are a bunch of tools which are pretty mature and pretty available in the market. So the crux of it is that since Pulumi is richly typed, it essentially has a native support for a lot of custom resource definitions, which can be used out of the box or can be used in form of in-cluster operators for the CD platforms. Then there is something called as dynamic provider support. So there are three types of resources essentially in Pulumi. One resource is the static set of resources which are coming out of the box. One is the dynamic provider resources, wherein you essentially try to bundle the resources on your own, and these resources are meant for use by you only and cannot be shared across. And then the third category is shareable resources, wherein you create the resources which can be shared across. So just imagine them as Terraform resources, if you have worked with Terraform, because like mostly I'll be making references to Terraform throughout this talk, because that's the tool which most of the people would have exposure with. And this is where like dynamic provider support is there in Pulumi. So you can actually write your own resources and you can share. You can have such kind of like shareable and non-shareable segregation as well with respect to resources, but that is not possible in Terraform. Like now, if you have to do that in Terraform, you will need to write complex modules, and then it would be a module derivation only that you would be doing. And from an infrastructure reuse and modularity perspective, the things that I talked about, the class patterns, there is something called as component resources as well, which I'll talk about shortly. And the other things like the Pulumi packages that I talked about, all of those things make Pulumi really powerful. Yeah, and then as I already mentioned that there will be some kind of integration test supported for Terraform, but there are no unit tests or property tests supported, or any kind of assertions supported with respect to the end state. And now there are validations which can happen in static manner, but then Pulumi offers more support and real testing support for property, unit, and integration testing classes. So this is where Pulumi excels. Coming to specifically import code from other IAC, that's real advantage. So you can essentially have Pulumi import code from AWS CloudFormation, from Kubernetes YAML, from Helm, from different like Terraform, Azure ARM, you name the tool, the IAC tool, and Pulumi would have some sort of converter. Even it can convert custom resource definitions to programming language specific code. That's the beauty of it. However, Terraform doesn't have such a capability. Recently, Terraform developed something which is called CDKTF, which is Cloud Development Kit Terraform, that supports writing code in some programming language and then having that converted into the HCL style, and that is supported through an intermediate JSON representation. So CDK-TF is the latest edition in the Terraform world for the CDK or the Cloud Development Kit part. But then that is not as mature and not getting active attention. Whereas like Pulumi already excels at this particular thing. Then when it comes to secret management, that's another win for Pulumi. So if you have automated in Terraform, you would understand that secrets are really critical, and even though they are critical, they are not encrypted, or they are not kept hidden or redacted from the outputs. Now there is a way to have your output turned sensitive equal to true in Terraform, but then you won't be able to have your secrets hidden from, let's say, the state file, or any kind of logs that are getting shipped as part of your output. Now some CI/CD platforms will redact that by auto-detecting that Terraform probably may have secret by picking the words and doing a word-based or token-based redaction or obfuscation. But then that is not how the system should work. Pulumi, on the other hand, has secrets encrypted in transit as well as in the state file. So you won't have the secrets exposed at any point of time, be it the logs, be it the state file, be it during the transit. So that's a pretty good advantage. So in Terraform, you will have you will end up having secrets revealed, but then Pulumi doesn't leave a choice for you. And then another good thing, which probably will be a bit surprising for many of you, would be there is a concept of aliases in Pulumi, wherein you essentially can have a resource reparented to another component or resource. So I can, without destroying a resource, reparent that to another resource or another component. And that's where I can even change the name of resources without destroying. That's achieved through aliases. Again, that is pretty advanced concept of Pulumi. I won't be talking about it, but uh, if you were to do something similar in Terraform, a destruction would happen leading to outage, and then you will have the uh, let's say resource creation happening. And like there are a lot of benefits which Pulumi comes with. Again, like these were just a couple of them, uh, and then we'll see some once we make progress through the session. So let's get to the architecture of Pulumi, and this is where things will start getting more clear as to how we are essentially having all the things coordinated. So there are three major components or three major pillars of Pulumi architecture. One is called the language host. One is called the CLI and deployment engine. One is called the resource providers block. So essentially, language host is further broken down into language executor and language runtime. Again, for abstraction, I have not shown because that will be too deep. But ultimately, the goal is that you tell your program that I am going to have my resources developed in, let's say, Python. I am going to have resources developed in Java. I'm going to have resources developed in JavaScript. So language host, as the name suggests, it takes into consideration the runtime. It prepares the runtime for your program execution, and then it gives a command that, okay, I have got this program, I want to execute the resource creation for this particular program. Go ahead and have the handle given to the deployment engine. Now deployment engine will keep on checking whether my current state of infrastructure meets the desired state as specified in the program or not. And this is where it is going to interact with this data store, and it is also going to interact with providers. Now providers, essentially all of these are like mostly binaries that are interacting over gRPC with each other. So provider is interacting over gRPC with the deployment plane. The language host is interacting with the through gRPC with the deployment engine, and so on. Yeah, and these providers are essentially providing the actual APIs to interact with the cloud providers like AWS, GCP, or any other resource providers like Kubernetes, vSphere, Aviatrix, yeah, or Vault, or Vulture. Like you name the provider, and probably you will find some set of resources available in Pulumi. So this is where resource providers are providing you the way to interact with the APIs of the resources or the actual providers. A deployment engine is essentially having the state management done, and it is checking whether there is a drift between the current state and the desired state. And language host is essentially the one which is launching the runtime. It's giving the handle to the deployment engine and telling, okay, go ahead and please execute this state. So that's the first level of how the architecture looks like. Now we'll start getting into one step kind of down, and we'll see each of the components, and I'll also start showing you some stuff on the terminal. But before that, I'll show you the providers page at the Pulumi site. So let's go to Pulumi providers. So if I come to the providers, you see that there is a rich set of, like, you have providers of the kind of WAF CDN capability providers. You have registry providers. You have authentication providers. You have independent stack providers and resource providers. You even have different like data solutions available. You have interconnect and network connectivity solutions available. Like, it's a pretty rich platform. And then for some of the providers, you see there is a mention of classic versus native. Now, native is a keyword which is pretty popular in the Pulumi world. And why it is popular is because the providers that are termed native are essentially having some really, really high SLAs. When I say SLAs, these are service level agreements. So if a provider is a native, as and when some new feature or a new resource is getting launched on that particular provider, Pulumi will guarantee you the same day inclusion of the resource in form of Pulumi resources. So let's say Google Cloud was to launch a new feature for mutual TLS of load balancers. Now, Pulumi at the day of the feature launch itself will incorporate that resource so that you have the same day availability of the resource. So you won't need to wait for, let's say, X number of weeks or months for someone to go ahead, start to contribute or push anything in the Terraform, let's say, provider resource or repository or update that. Is the same day support that you get through the native one. Whereas classic modules generally are the ones which are derived from Terraform. So this is where Pulumi made a strategic move. It started with having Terraform related resources reutilized. So behind the scenes, if you just debug the Pulumi, let's say, uh, life cycle, you will get to see that there are Terraform APIs getting called. So classic provider generally would be pointing to existing Terraform resources or providers. The native ones are going to be the native resources written directly for Pulumi. And this is where like Pulumi has collaboration with the providers and it offers native. So you will see a lot of like AWS native, GCP native, and you'll see a lot of native providers as part of that. So that gives you same day guarantees. And some of these providers are currently in preview, so you may not get same day guarantees in the preview or the beta or alpha phase. But yeah, you can see like even Ops Genie, Okta, you have like alert manager and notification manager, incident response systems, whatnot, storage provider, Portworx, and also it's a pretty wide support that it gives. Okay. All right, so coming to language host, this is where we start to see the flavor of Pulumi, and we first need to start with Pulumi new. So this is where we'll get to our terminal, and okay, yeah, okay. So this is where I have Pulumi, and I'll do a Pulumi new. Okay. This one is already taken. I'll just go ahead and have you shown on this particular thing. Yeah, so what you do is you start with the, and this is a lab that I created for follow along. Likewise, we have a YAML related lab. So what we do is we first have Pulumi package or binary installed. After that, we add the path for Pulumi, and then we essentially can choose to define a storage backend for managing the state for Pulumi. So this is where you have the GCS bucket, the Google Cloud Storage bucket, wherein I'm storing my Pulumi state. Yeah, and I do a Pulumi login, and this particular login command will essentially have the GCS backend taken as my state, so that I have my state management done in a reliable manner. We just need to make sure, because we are going to use Python as the language runtime, we just need to make sure that we have Python 3.7 or above. These days, if you install Python, it will come with 3.9 plus. So that's where you are going to be safe. But then the important thing is, because if you don't do this, you will end up getting into errors wherein you probably would have a partial bootstrapping of your Pulumi repository done, and then during execution, it will fail. So just you need to make sure that you are having these packages, because Pulumi, when it is doing a Pulumi instantiation, it will require the pip package, etc. So this is where we go ahead and we have support for we have support for pre-built templates. So templates would be on the lines of AWS C#, AWS Golang, JavaScript, and so on. Likewise, GCP, Python, GCP, JavaScript, GCP, Kubernetes, and all. So that's where you have pre-built or pre-baked templates. So whenever you do a Pulumi new, it is going to define the runtime for you. So that's where the language host component comes into picture, right? So this particular language host component comes into picture, and this is where when we will be defining our runtime, we will do a Pulumi new and GCP Python, because we need to have Python specific runtime, and I have access to Google Cloud for now. So I'll be creating my resources in Google Cloud. If you were to have some resources in some other cloud, you would have gone ahead and instantiated Pulumi new with, let's say, Azure C# or Azure JavaScript and so on. And this particular thing brings up a boilerplate or a program for us. So that's where let's go ahead and let's try out on our own. So I'll just have a directory created, and then I'll just cd to that directory. So let's go ahead and make a directory. So let's say this is Pulumi demo 99. Okay, and we go to this particular directory. And all of this code that I'm talking about, right, it's something that is available as part of this repository. So let me first give you a QR code which you can probably scan, or you can get to the repository quickly. Okay. Okay, so this is the QR code for this particular repository. If you want to have this, or else like the tiny URL is, I'll show the tiny URL as well. The tiny URL for this is this ADA 2023 Pulumi. Yeah, so you can either do a QR code scan, or you can just have this ADA 2023 Pulumi. Okay, so this is where the code that I'm walking you through you would get. So I'll just go ahead and make this particular thing. I'll just cd into that. So Pulumi demo 99. Now what I need to do is I need to do Pulumi new GCP Python, and then I'll be having my config and then GCP project ID. Now this is where I'm doing two things from one command. So first is I'm telling that I need to have a GCP Python specific runtime stack brought up, and then I am telling that I want to set a config property, which means I am explicitly telling that there is a key value map. The key is GCP project and the value is my project ID. I need to set this key value map as a configuration that will be referenced by my Pulumi deployment. Now, Pulumi for GCP provider essentially uses the GCP project to identify where will the resources land up or get deployed, right? So this is where when I could have done this with Pulumi config command as well. I'll show that in the YAML lab. But then Pulumi new GCP Python config will do two things. One, create the runtime for GCP Python stack. And then the second is it will have a configuration created. So let's go ahead and have this executed. But before that, I'll need to export a variable project ID. I'll do project ID equal to, this is the name of my GCP project. So for the people who are not that much familiar with GCP, this is my project ID, and this is essentially this workshop 00 essentially is the project ID, and it is telling that I'm going to have my resources deployed. Like in AWS, you have concept of accounts, sub accounts, and all, right? So in GCP, you have a concept of projects. So here in my project, I'm going to have resources like the Kubernetes engine, storage, Cloud SQL, virtual machines, and all. Yeah. So this is my project ID, and let me now paste this. I'll need to just put dollar here. So now this will ask me, this will show me a wizard, okay? And this wizard is essentially going to define the boilerplate for us. So we have enter the value, the project name. So I'll just hit enter because I want to keep my project name as Pulumi Demo 99 only for this demonstration. You can provide some metadata description. I'll again keep it to the default that is coming. And then it is going to ask you for creation of a stack. Now, stack is essentially an instance of a program. So assume it like a workspace in Terraform, but then essentially from a Pulumi perspective, it's a representation or it's an instance of a program. When I say program, it's the actual program that is going to run in Pulumi and is going to instruct what all resources are going to be created, modified, deleted, or so on, right? So this is where when we create a stack can generally, like following good practices, we can have stack aligned to some SDLC phase or software development lifecycle phase, like dev, stage, prod, int, UAT, yeah. Or we can have it corresponding to feature branches, or we can have it corresponding to business units. So if it's a multi-tenant environment and we want to have business units, but all of them have to use some different configurations, but primarily need to have, let's say, similar kind of templates used for the very same application, let's say, for example, then in that case we can use the concept of stack so that we can have different representations or instances of the same program with different configuration values and different properties probably corresponding to the resources. So I can name my stack anything. I'll again keep it the default, which is dev in this case. And then if you are doing this for the first time, right, you will actually be required to generate a personal access token, a PAT token on Pulumi, and you will see a pop-up for that. So this is the Pulumi UI essentially. So if I go to Pulumi, just to sign in, this is how your dashboard would look like, and you will be required to go ahead and have a token generated. So the link for generating that token is essentially going to look something like this. Pulumi account / tokens, and you essentially would be you would see a pop-up here in the wizard only. So before even getting you the project name specific option, it will ask you to go and provide a personal access token. That way you will have the registration made in Pulumi. So you see that there are going to be some stacks already defined, like Pulumi demo 0001 99. We see 99 is already appearing here. Now if I get to 99, it is going to have the configuration and the project essentially associated, and all the data and the related, let's say, metadata and the policies are going to show up here in the UI. So this is free. This particular UI is free if you are using an individual capacity, and with that you get the Pulumi AI feature as well, which we'll get to shortly. So this is where my stack has got applied. Now if I do if I go back to my steps, we have essentially got a structure or boilerplate. We should have got a structure or boilerplate like this. So let me go ahead and have a tree command. It's a pretty big one because it's a venv or virtual environment as well. So I'll just do an ls first. So you see Pulumi dev YAML. So how it got created, Pulumi, and then dev. Dev is the name of stack. So if you were to have staging, then it would have added another file, pulumi.staging.yaml. If you were to have prod stack also, because you can have multiple stacks instantiated. So you can have the same code base, maintain the properties for dev, maintain the properties for staging, maintain the properties for production, and so on. And likewise for business units, and likewise for multi-tenants, and so on. Yeah. So if I just do a cat on this, you see I have the config property GCP project that I have got here. Pulumi YAML is the essential one, which is containing the metadata like virtual environment name, which is venv by default, the description of the project, the runtime information, which is getting used by the runtime executor and runtime engine, and the name of the Pulumi program itself. And then main.py, which is a good boilerplate for getting started with, it is going to pre-populate some code in form of Pulumi template. And then it's just telling that, okay, I have a very simple Python program here, import Pulumi, and then from Pulumi GCP, which is Pulumi package, we import storage. And specifically with storage, we go ahead and we create a bucket named my bucket in the location US. And then I export an output like Terraform output. You have outputs.tf, right? So here you have pulumi.export, and then this is the key of the output, and this is the value of the output. So what this will do is, instead of like imagine it were to be Terraform, you would have done output.tf, and then in output.tf you would have defined a variable with some value. That value would have been module dot, let's say, name of the module dot bucket URL, something, right? So instead of doing all of that, it's pretty simple. You just provide the key and value and you are sorted, right? So that's where you have this particular program getting pre-populated. And so this is the template generation. So we'll take a pause on the demonstration here and get back to the deck for now. So this is where with the Pulumi new thing, you essentially got a project. This project actually had some program and templates created. The program in our case is what? Main.py. If it were to be, let's say, node.js or JavaScript or TypeScript, it would have been index.js. If it were to be Java based runtime, then it would have been some Java specific .java program, right? But in our case, it's a main.py which gets created by default, and it's the program which Pulumi will be considering for creating the resources and related bundles like Terraform main.tf. You can consider it like that. And then stack, as I mentioned, is there for handling properties differently. So you can have in the same project multiple stacks. So the configurations for different stacks are essentially independent, and they are configurable in an independent manner, and you can essentially have some attributes or tags associated to stacks as well in order to perform some intelligent decision making towards the end. Again, that's an advanced topic, so we may not get time to get into that. And then a good part, I would say, like a very, very good part for this, if you have worked with Terraform, you will be able to relate. What if I were to have a module in Terraform and I were to have some outputs exposed from that module? Now, if I were to have the exports from the module in form of outputs, I would have to copy those output values and then put in, let's say, the input of the other module if they were not to be in the same repository, or I were to use a concept of submodules in Git, or I were to use a single mono repo wherein I can have the outputs probably shared because I have multiple modules which are getting defined as part of Terraform. So that becomes cumbersome, and that is not that easy, and mostly it's a manual, or it requires some manual intervention. In Pulumi, you can essentially have stack outputs referenced from across the stacks. So if I am getting an output as part of dev stack, I can essentially have it referenced in QA. I can have it referenced in prod. And likewise, I can have any other stacks value getting referenced from other stacks. So this is where you don't really need to hop codes. You essentially can pick stack from other Pulumi projects as well. So this is where a concept of organization comes into picture, and this is where when I was showing the bootstrapping portion, you would have seen that it should have so when you will actually be bootstrapping, right, it will give you a disclaimer that you should provide either a stack name, or you should give a fully qualified stack name that would have a prefix of org that you want to identify your stack against, / the name of stack. So it would look something like this. Org name where an org name is a placeholder which you can fill, and then you have a stack name like dev. So Pulumi gives, and this is called fully qualified stack name. So this is where you have you can actually reference outputs of different projects and their individual stacks as part of your own program. So that's pretty amazing. Yeah. So yeah, this is where we have this first boilerplate taken. Then we come to the deployment engine component. Now this particular deployment engine component is there to determine the drift between the desired state and the current state. So what is deployed, what is not deployed. So if you see here, it's pretty kind of similar or analogous to how you will see in the other IAC tools. You will have plus, minus, or you will have a tilde sign. Plus will tell the resources are getting created. Tilde will tell that you are having some in-place upgrades done to the resources, and minus sign or negative sign will show that the resources are getting destroyed. One property of Pulumi is that if it has an in-place upgrade to be done, or if it has a resource replacement or substitution to be done, it will automatically bring or attempt to bring the new resource first before removing the older resource. So in Terraform, you need to manage this using lifecycle and put some conditions that, okay, I want to have recreation done before, or destroy before, or destroy after. Pulumi takes that into account on its own, and it attempts to create the resource first before replacing or removing that. So that's another feature of Pulumi. So you have resource creation happening here. So we'll see a similar kind of thing in our demonstration when I start continuing with that particular thing. And then there is an interesting thing called Automation API, which Pulumi has launched, and it's relatively new to the Pulumi ecosystem. This is where you get a programmatic interface for having Pulumi literally embedded in your applications instead of relying on Pulumi CLI. So now you can use APIs and interfaces, and essentially you can go ahead and run Pulumi related stuff as part of your embedded application program. So this is where it can be used as part of CI/CD automation. It can be used as part of any alerting mechanism you want to do, any checks you want to perform, any validations you need to do. All of that is something, and as the name suggests, it's essentially enabling you on automating stuff. So this is a very rich feature which Pulumi has launched, and again, Pulumi has an edge over other platforms and providers. So this is where we got to create a project. The property of project is any directory or folder that has a Pulumi YAML file, regardless of whether it's implemented in Python, it's having runtime as Java, JavaScript, or YAML. It will have a pulumi.yaml file. Now, pulumi.yaml file, as we saw here, essentially was having the metadata corresponding to the runtime and the program and the project. So this is all project specific metadata that we are containing here. And this is where we define the runtime specifically, and we define any other properties like description, or from where we need to refer the code base, etc. So all of that is something in the YAML demonstration. I'm going to show you how to reference code base from some specific directory when working with Pulumi. And then there is a rich set of attributes that you can utilize in the project Pulumi YAML file. That's where I have given a link to the documentation, and you should have a handout of the decks, the deck, as well as the deck is there on the GitHub repository, so you can check that there. And then this is more about Stack. So Stack essentially has a couple of more properties which like would be good to understand. So these are like, you can essentially have something called as stack references given with fully qualified stack names within the code itself or program itself, in order to derive some results from outputs of other stacks, and then take some decision or do a conditional matching or do some, let's say, looping over any of the values that you are getting from other. So inter-stack dependency is a very cool feature of Pulumi. And again, like, that's something I'll point you to an example that you can check after the session. And then this is where you have component resources coming into picture, and I'll show you an example towards the end for component resources as well. This is where we actually have a logical grouping of resources and configurations happening as part of our Pulumi configuration. And we have even the main or the top level, like when we talk about classes and all, we have like exception classes and all, we have base exception class and so on, right? So in Pulumi, we have component resources, which essentially contains all the top level resources in a program, and that is called Pulumi stack. So that's the top level entity, and that is in itself a component resource. And what component resource is capable of doing is that it can define some structure for you. It can give that, okay, when I have some resource creation happening, have it through some constructor. When some resources getting removed, have it through some destructor. Have some getters and setters for resources set. So essentially, I'm defining a proper blueprint for a resource, and I can have my custom resource created by combining the different features, or I can have some bespoke configuration implemented using custom resources. So this is just an example of custom resource wherein you have a VPC that automatically gets or virtual private cloud that automatically gets built based on recommendations or practices that you want to enforce. So think it of like you were to exercise some standardization and governance in your project creation stack. So you are part of platform team, you are part of infrastructure team, you are part of center for excellence or center of enablement for your organization, and you were to enforce some standards and governance. Now, how would you have achieved that? Probably guide everyone to follow some playbook which utilizes some component resource stack when creating some resources. This is where you will find you will follow a common blueprint for creating similar nature resources, right? So we'll always have the VPC created following the best practices that have been laid out by the component resources. And then another example that I gave towards the very beginning is regarding like Kubernetes cluster, wherein you can have a common blueprint depending on the target that you want to have deployed, and you have EKS, AKS, GKE clusters created. So if you want to create a new component resource, you just extend from the component resource like this, and I'll show you an example towards the end because that is going to be an advanced example. So you go ahead and extend that component resource class and then have your constructor written, and that's how you go ahead and implement that. Okay, so let's get and see the rest of the example. Yeah, so as of now, we had this structure of boilerplate created. So I'll do an ls. So we have all of these things, and you have requirements.txt, which is going to have Python and Venv packages. Okay, so what we need to do is we essentially got this particular configuration pre-baked. So in order to deploy some stack on Pulumi, what we do is we just do Pulumi up. So like in Terraform, you do Terraform plan and then you do Terraform apply. In Pulumi, you do something called as Terraform preview, Pulumi preview and Pulumi up, right? So Pulumi preview is currently in preview mode only. It's experimental feature. But Pulumi up is something in which you can check the whole kind of plan, and then you go about seeing how the things look like. So I'll first make a change to the main pie because I think I have a bucket with the same name already present. So I'll change the name of the bucket just to make it unique. My bucket ADA 2023. And I'll then do a Pulumi up. Now, Pulumi up essentially will show me some plan. Okay. So this is first installing. So if you were to not have the dependencies like Python 3 pip, etc. that I talked about earlier, then in that case, you would see an issue here. The plugin, etc., may not load correctly, and you may end up not having Pulumi run successfully. So this is, and you can actually view this in browser as well. So I'll just copy this and get to my other browser wherein I have. So it depends whether you want to follow terminal or whether you want to see this in browser, and you can actually see the diff as well. So this diff is essentially the resources that are going to get created. So you see there is a URN or unique resource name that is associated with each resource or component that is getting created as part of Pulumi. And this is where the first component that is going to get created in Pulumi is the base component, which is the stack itself. So this is where you see a plus on stack. So first the stack will get created, and then every resource will be parented to the stack. So that's an important thing. So if I have a GCP bucket getting created, that bucket will have a parent, which is the stack itself. And this is where you see the URN name, how it is getting created: Pulumi dev, Pulumi demo, and then stack, and then the whole name, and likewise the bucket. So this is just making sure that you have each resource with a unique resource name, right? And it's getting parented in the right manner. And then you see that bucket output is something that will get created. So this is how you can see that on the UI. And again, like once you have a pretty bloated infrastructure and you want to see diffs and all, this can be a good thing or a plan kind of to view. I can actually view from the terminal as well. So I just need to go to details and then click on details, and I'll see the same thing. And then when I click on yes, essentially it starts creating the bucket, and it will first create the stack, then it will create the bucket. And you see it gave me the name of the bucket as this. Now I'll go to my Google Cloud Console, I'll write cloud storage, and I should see my bucket ADA23 something. Yeah, so this is the bucket which got created. Now this bucket is essentially created by Pulumi. We will take this demo further, and we will have some static website hosted through this particular bucket and served on the internet, so that even you all can access that website. Okay. So this is like this particular demonstration that I'm showing is a lab that I authored. So that has been inspired by the official Pulumi documentation. So I'll anyway have I have this code base as part of Pulumi demo folder or directory in the Git repository. So anybody, if you want to follow this, you can follow this afterwards, and I have linked the relevant resources here as well for understanding this better. So yeah, like this is just showing, the lab is just showing that we have the Pulumi up done. It is creating resources. It ends up creating resources. We get the bucket name, and this is the place which we have reached. Now we can actually, though we got the output here, but what if we want to have the output referenced afterwards, or we want to see the output later, like we do Terraform output, right? So the Pulumi stack output essentially will give us the same thing. So it will just give the name of the bucket. So as many outputs you have, just the key you have to pass here, and Pulumi stack output for the corresponding stack will give you the results. And then let's start modifying the program to host a static website. So first we need to create an index.html that is going to just do a hello Pulumi. So I'll just copy this, and I'll have an index.html created. So now my directory looks like this. So I have an index.html. Now I will essentially go ahead and I'll modify my main.py file. Now main.py file is essentially going to have some new properties associated. So in the bucket that we created, now we need to host the object, because I told that we will be serving the index.html page from the bucket. So we have already got the bucket here, but that bucket doesn't have any object. So what we need to do is we need to create a bucket object, and for that bucket object creation, we need to use the Pulumi SDK for Python. So storage.bucket object is the method, and it will take index.html, which is the file that we need to pass, the name of the bucket in which we need to have the object hosted, and essentially the source, the actual content of the file. And then after that, our the main py file will essentially look like this. So this is the new addition that has happened. Now if we go ahead and we deploy the changes, so let me first make the changes. Okay, and let me do undo because my bucket ADA. Okay, I'll keep the same bucket name so that it's consistent. My bucket ADA 23, and then I'll do a Pulumi up. And what is expected? The GCS storage object will now get created. And if we see the details, it's just telling that we have two things unchanged. So it will not show the unnecessary stuff. It will not show the resources. It will not show refreshing, recreating, or something. It will just tell how many resources are left intact, and how many resources are to be created, modified, or destroyed. And then you can get the details, and then you can go ahead and deploy this. So now what will happen is it will start attempting to create, and it will have the index.html brought to my storage bucket. So here is my index.html file. Now what I need to do is I need to go ahead and tell that, okay, I need to have my storage bucket website property essentially updated so that it takes the website argument in order to serve the static website. And then it will also require some role binding or identity access management that I'll need to tie that along with, so that I can tell that, okay, index.html is a file to which so and so people will be having access. So I have just written all users so that we can have a public access for this particular index.html. And then our bucket object will essentially look like this. And we can add a bucket endpoint export value here as well, so that we can have the bucket endpoint exported, and we can use that bucket endpoint in order to see whether the page is getting served. So ultimately our file will look like this. So we have the storage bucket with the website property for static website hosting, wherein the main page is index.html. We have the object index.html of type HTML, which is getting served from the index.html content. We have IAM role binding to tell who all have access to the index.html file on the bucket. And then we are exporting bucket name, which we already saw how it is getting exported. And we have the endpoint as well for the bucket. So what I'll do is, since this is not a good formatted file and I'm working in TXT, the text editor mode, I'll just go ahead and I'll pick from my from this, and let me, okay, and I'll change the bucket name here to EDA23. I'll go ahead and make a change here. And for the people who are having questions, I'll be addressing them towards the end. So we'll have like 15 minutes slot towards the end so that we can have all your questions answered. So feel free to gather your questions. Be prepared to kind of have a constructive discussion towards the end. Yeah. And then I'll do a Pulumi up. And what is expected? IAM role binding, change in the bucket because we had a property, and we have okay, there is a change in the bucket content type as well that we added. Okay, so let's see the details. What is happening? It's telling that it is going to have uniform bucket level access turned to true. That's an in place update. We are going to have our IAM role binding created, and then the bucket object is getting replaced because I have added a text HTML. Probably I can, just for avoiding any issues, comment that out as well. So instead of let's keep it to the original one. Okay. So now you see it's just showing the intended changes. So we'll go ahead and have the application done so that the resources get applied. And we have the resources now. So now we'll go ahead and we'll do a Pulumi stack output, and it should show the endpoint. This is the storage endpoint, which should ideally be serving the web page. And now let's get back to the demonstration. Okay, now if we curl this endpoint, right? So what I'll do is I'll just copy this and I'll curl this. So curl. You see, now I'm having an HTML page served from my Google Cloud Storage bucket, and all of this has been powered by Pulumi. And then once you are done, you can just do a Pulumi destroy, like Terraform destroy, and it will just delete the resources. And then in order to delete the stack itself, there is a delete stack. There is a stack rm command that you can essentially use. So that's where this particular demonstration gets wrapped up. We'll get to the slide deck again, and we'll cover the remaining two demonstrations shortly. Okay. So this is where Pulumi has a lot of converters, as I told. So ARM Azure Resource Manager to Pulumi converter. This is the link for that. So once you review the deck, you can find the link here. You can essentially convert CloudFormation to Pulumi, and you can also have Kubernetes Helm to Pulumi, any CRDs to Pulumi. There is a YAML to Pulumi translator. There is a Terraform to Pulumi. We are going to see a demo for YAML and Terraform. And then you can essentially write code in one language in Pulumi, like Pulumi YAML, and then you can convert that using Pulumi convert to Python Golang. So you can have YAML written in Pulumi converted to something else. So that is where you have a lot of converters that are available from Pulumi. So let's get to the remaining demos that are there. So we will now have a YAML Python, a YAML to Python converter demonstration, and this is again a public link. So I have already linked this to the repository. This lab again was co-authored by me. So this is where you will have Pulumi on Google Cloud with YAML. And we'll just go ahead and start with the stuff. So I'll just make the font size a bit big. So we are doing the same set of setup here. We are first having the Pulumi binary. We are setting the path. We are having the cloud credentials set for Google so that we can interact with Google resources. This is pretty important. I did not show this step because my my Bastion host or the jump host was already having an identity, workload identity or service account association. Like you would have heard of Cube2 IAM or GCP service account on virtual machine or virtual machine specific service account association. So that way I already have access to the cloud APIs through the identity management stuff, but you ideally would be required to do something like this. And then you can have a GCS bucket backend. If you wish to have something like AWS S3, you feel free to go about that. So let's go ahead and build a YAML based demonstration now. And then we will convert that YAML code base once it's deployed to Python, and we will see that there is no change after conversion. So we'll first make a directory Pulumi YAML demo, and I'll just get into Pulumi YAML demo. I create a Pulumi YAML file here, and let's understand the structure of this Pulumi YAML file, because this is having something new. So now I have main, and this is where I'm telling that I want to reference the code present in YAML repo directory. So I have specifically called out that I want to have the code reference from YAML repo directory. And this is where I'll be creating a YAML repo directory next. And I'll just create another initialization of Pulumi YAML under that. So this is where now, like in Python, we were having underscore main.py, like in TypeScript, JavaScript, we will be having index.js. In YAML, we have name as pulumi.yaml only. So this is where, like, this is pulumi.yaml, but this should not be confused with pulumi.yaml that is here, because this is essentially the program one. This is essentially the metadata one for the project level. So we will have this thing, and again I'll need to change the name of the bucket, which I'll do. Okay. So let's get to YAML repo, and then Pulumi YAML. And I'll have again the bucket name changed. So I have my bucket, let's say YAML ADA, and then rest of the things I can keep as same. Now what this configuration is telling is that I want to have a resource created named my bucket YAML that has to be of a storage bucket kind. And then I need to have some specific properties corresponding to the bucket, like the region is US, the page that is getting served is index.html. I want uniform bucket access. So all of the things that we saw in the previous Python example, those have been incorporated and translated into YAML file and just shown here. Now, once I have done this, the next thing that I need to do is I need to have my stack initialization done, because I did not do that. I did not create any YAML related structure, right? So I'll go ahead and have, and this is where, like, Pulumi, essentially you can set a config passphrase as well, like when you have SSH interacted with, you pass a passphrase, right? Or in order to configure a config store, you pass a passphrase. So Pulumi config passphrase is something that you can pass. Without you providing the passphrase, you will not be able to access the configuration. So that is another good point, right? So you can essentially pass a passphrase like this: export Pulumi config passphrase, and then you can pass a passphrase. So this is where, like, you can already understand how good it is from configuration and secret management perspective. Okay, and this dev YAML. Okay, and I'll just export my config property. So you recall that in the Python one we had Pulumi new GCP Python -- config GCP property, but here we are doing explicit setup of the config property, right? So this is where, like, you can actually create config like this, or there are other ways as well to define config by directly having config added. So if you do Pulumi config, you essentially will see the configuration key value here. And now is the time we should do a Pulumi up. Invalid memory address and null pointer exception. Okay. Probably some formatting issue. What was the error? Let me try again and see. Okay, segmentation violation. Failed to discover plugin requirements. Right. Okay, Pulumi lab dev YAML. Okay, what I'll do is I'll switch to Pulumi lab. So here what we need to do is I'll just Pulumi up. Okay, right, this is fine. So I'll have Pulumi YAML modified and made YAML just to mimic what was there, and I'll do a Pulumi up. Okay, unable to find main Python and YAML repo. Okay, fine. Yeah. So what I have done is in the in the in the other one, the YAML one, there is some issue again. In interest of time, we won't be troubleshooting that, but you essentially would be having the YAML resources created, and once that is done, you need to have one command essentially run, which is Pulumi convert language Python and then out. So this is where you will have a structure like this, the one in the Py repo. So you will have a Pulumi YAML created, a main.py created, and if I do a py and main.py, see that the YAML resources have got converted to Python automatically. So what we were having as part of YAML is something which I will show you. This particular configuration that was there as part of YAML got auto converted to the Python one, and then after that I went ahead and I did a Pulumi up, and that just required me to change the directory from which I wanted to. Oh, it's a Python thing. Okay, let me do it. Probably we'll be able to get to this. So it's a YAML. Okay. Yep. Okay. Now let's do Pulumi. Okay. Awesome. Okay. So this is now reading from the YAML one. So what I'll do is I'll remove the Python one so that you can see this in action. Now we just have the YAML resources. I'll just run the Pulumi converter so that you see how the conversion happens. So first thing is we'll see if there are any resources that are to be changed. Pulumi up. There are no resources to be changed, which means we have the bucket deployed. Now what we'll do is we'll just go ahead and have the converter command run. Now you'll see that a PyRepo folder will get created, and this is where all the dependencies again that I talked about towards the beginning will be getting referenced. And now you see a folder appeared, and this particular folder, PyRepo, has main.py, and main.py has the actual code. And this is where now I'll go ahead and I'll just replace my Pulumi YAML file with PyRepo. And once this is done, now I do a Pulumi up. Now it is no longer referencing to the YAML code. It is now referencing to the Python code. So now if I go ahead and even remove my YAML repo, that would work fine. So essentially we created code in YAML because probably someone created that in YAML. Maybe they were finding it easy to work in YAML. We ported that code from YAML to Pulumi. Likewise, you can convert from YAML to Golang to Java and so on. Yeah. So this is again a self-paced lab that you can reference with the good set of instructions. And the last one is essentially that I'm going to show you is the conversion for specifically a repository, a Terraform code that I'm going to show you. So this is the code base which we are going to see. This is the Vault infra setup. We're in Terraform. We have main. This main has vault.tf, a pretty big file. Then there is this example TF-vars that are present here. So what I'll do is I'll convert this Terraform code to Pulumi code. Okay. So first thing is we'll need to have a clone of this repository done. Okay. And this is where I get the clone of the repository. Now I'll get into Terraform. I'll specifically have the main module converted, and then you would have already guessed Pulumi convert from Terraform language Python out Pulumi. So I'll have a new folder with Pulumi related artifacts created by the name of Pulumi. So let it convert to Terraform and we'll see the output. It will just happen pretty quickly. It doesn't need to wait for long. It will convert the files and we'll have that code also seen. So let it convert. Okay. Yeah. Happening. Okay. So now we have a Pulumi folder. Now if we do Pulumi, what are we expecting? A main.py, vault.py. Okay. So vault.py is something that is getting referenced by main.py. Okay. See a pretty big file which is kind of written, and you see how much it would have taken for you to write this code on your own. Yeah. And Pulumi has done this in a jiffy for you. And then if I do a main.py, now it is just passing to the Vault class. So see how classic it is here. It's having some class variables, some normal variables. It's having Vault class created, and it is taking care of everything. And it's so decent or sophisticated here. And then you can just do a Pulumi up and it will get into the Pulumi folder. And it will do the necessary okay, stack creation, and also we'll skip that in interest of time, but you can try this on your own. Yeah. And the last thing before I hand it over to you for questions and answers, this is where Pulumi recently launched a new feature called Pulumi AI, wherein it has integration with, you see, V4 Turbo and V4 GPT. And you can essentially define the mode of operation as explained, balanced, and code. And you can have the code created for TypeScript, JavaScript, and the languages that are written. So let me do one thing. Write a code, write a Python code, okay? And I can select Python as well, anyway it will pick up. Write a Python code which has, which creates a global external HTTPS application load balancer with PSC neg as the backend, which in turn routes the traffic to a service attachment for APGX organization. So it should create code for global external load balancer. It should create code for PSC neg. That's a GCP construct, private service connect network endpoint groups. Then there is a service attachment, which is a construct which binds with the neg, and then something around AppGX organization. So let's go ahead and generate the program. Okay. So it's telling what all it can do, what all it cannot do. Okay. And for the people who just want to test whether this conversion is happening fine or not, you choose the Terraform tab. It's free. Like, you go ahead, choose the Terraform tab, and have a similar kind of thing or whatever you want to validate written, and you will see the resources that will come. Well, I'm not saying they will be accurate and functional out of the box, but the kind of coherence and structure that you will get, it will be a good boilerplate for you to work on. So that way it can be a productive thing. If at all you are not much comfortable with, let's say, a specific provider. So what if I am getting to a new provider like Vault or vSphere and I don't have any clue? I have two choices. One is I make search on some search engine. The other one is I reference some code base or get some understanding from some code snippets from somewhere. Now that, so essentially this is a productivity thing. This should not be taken into consideration to literally write code for you. Many people think that GPT has enabled us, or the language models or foundational models have enabled us to write the code in an automated fashion by using something like generative AI. But that is not the goal of such kind of tools. These are productivity enhancement tools, and as of now, they are not in a state to be taken absolutely for deploying to even in dev environments. These code blocks may work a couple of times, but largely in complex code bases, they tend to break. Yeah, so this is just an example. And then the GCP component resource thing that I was talking about. So there is this particular example under the Pulumi repository. Again, I have linked this particular example. This is where you will see in the network.py, you have a VPC class that is having its own constructor. And this is where you see the VPC itself is creating subnets, it's creating routers, it's creating NAT. So this is where you are enforcing a standardization or governance or a blueprint wherein whichever VPC is getting created will have the subnets, will have the routers, will have the NAT. So this is where, like, you using component resources can go ahead and enforce some standards and have some custom resources created so that you essentially enjoy the best of reusability, modularity, and the blueprint approach, right? And this is where you see the code essentially got pretty slimmed down. You don't have massive code blocks getting repeated over and over here. So yeah, with that, I think I would want to wrap my session. This is the link to the repository. This is the link to connect with me on LinkedIn and Twitter. And I hope you got something from this session. And yeah, that's pretty much it. Thanks for hosting me. Yeah. Open for questions.
Thank you, Anmol. That was a fantastic session for me. At least it was an eye-opener. I mean, I didn't realize that Pulumi can do so much, right? Especially when you were showcasing like the portability, transferring between the different languages, and how fast you can really just translate that and then have the resources provision ready, right? I think that was me simply amazing. I mean, looking back the old days when I first started, right, this kind of feature was not available, but now it's like instantly available. And like you mentioned, right, this is actually a productivity tool to a certain extent. I think it helps a lot of us when we are dealing with virtual infrastructure. How do we actually manage that? We do have some questions on the chat. Let me perhaps project them. I think we'll probably have time for two. We have about 3 or 5 questions there, but let me just project this one. Right. So hope you guys can see the question. So the question is, how does the code-centric infrastructure as code using Python impacts the professional development and skill sets of developers? I think a lot of people now perhaps have the variety of choice, right, in terms of the tools, the languages that we see, right? Compare when we first started maybe 5 years ago or 10 years ago. It's a totally different landscape altogether. And what opportunity does it create for developers to diversify the experience and contribute to the infrastructure management? So tell us a little bit more. What do you think, Anmol, on this?
Yeah, sure. So this is a pretty, I would say, deep question. This essentially is pointing towards a couple of aspects. So first, we need to understand that every developer these days who is coming for developing, at least in the cloud ecosystem, has to possess some knowledge of cloud components or resources that they want to interact with. So let's say you are building a fast API application, right? In that particular application, you would be required to have some storage bucket interacted with. You will be having some interaction with, let's say, RDS or DynamoDB, some NoSQL database, some queuing mechanism, and so on, right? So this is where the developer really needs to know, okay, for this specific business logic, I'll need to have it realized in this form of technical way. And for that particular technical way, I have to rely on some system component or some cloud component that is going to be made available to me by some cloud resource. Now, this is where most of the developers end up writing code in their preferred programming language. And when it comes to them collaborating with the platform team or DevOps team, because not everyone is part of the DevOps team or platform team, right? So application teams generally are siloed, and they depend on some teams. Now different organizations may have them labeled as SRE team, platform team, DevOps team, and so on, right? So this is where you may be following a culture wherein you have a center of excellence, wherein you go with application team representing someone from their team as a lead application developer, and then they doing a decision making with the lead platform engineer so as to influence the whole architecture. But when we have teams which are distributed and siloed, it really doesn't fly. So this is where infrastructure as code, essentially through this particular approach, will make teams work in a more federated manner, so that you being siloed even will kind of have some influence or say in the way infrastructure is getting designed, right? So you will essentially have application code influence infrastructure, and then infrastructure influence application. And this is where you can actually find a sweet spot between platform team and application teams to work together, because now the ideas from application team could actually be given to the platform team. So what if the application team person knows that I have a memory store or Redis or Memcache and I want to do a volatile LRU, but the platform team member doesn't know about that? So you can tell that, okay, I will just make an LRU volatile configuration as part of my code base here. And this is where you just take it through Pulumi or have some CD. Like there are multiple. Spacelift is one such automated CD tool which orchestrates each and every aspect of pipeline, right? So you can have such kind of GitOps utilities leveraged. So this is where your skill sets are going to get augmented with some more knowledge on the platform side. So this is a very good thing for the developers, because they will get more close to the lower level design. Rather than just working at a higher level that I need to interact with some component, you will have a say in how the component should be configured. And that essentially will lead to a better kind of model from a reliability perspective as well. Because application team, traditionally you would have seen that when SRE people go on call, they generally don't have much context of application, and this is where they call someone from the application team to be on call. So this is where like two people get on call and then solve. Now this is where application team members can go on call independently and then have infrastructure things sorted out, and only the SRE team or the platform team will be required in let's say some simple cases to go ahead and just do a PR approval, and they are sorted. So this is where like it is going to thin that line further and bring these teams closer. So that's one of the benefits. I
see that a lot, especially when you have teams that are newly formed, and this is perhaps an alien kind of a concept, or in terms of how you work well with each other, right? So I think you rightfully pointed out we need to upskill and maybe venture into the other side, whether you're coming from SRE or from a developer point of view, to really make things better. Perhaps we have time for one more question. Let me just project this one. Okay. So the question that is on the screen is saying that considering the dynamic nature of the cloud environment, how does code-centric infrastructure as a code using Python adapts to changes infrastructure requirement? I think this is very, very true in our current development of the cloud, right? Things change every 6 months at least, right? The tools have new features and whatnot. How do we ensure seamless updates and scaling of resources? I think that's a very common question. Anmol, what's your thoughts on this one?
Yeah, so first thing is, since you are dealing with a programming language, this is where you would be less dependent on client version dependencies and upgrades, right? So you must have seen that with Terraform, with 1.5, something gets introduced, some options get introduced, experimental feature get introduced. Now, in order to leverage some other feature, you will need to have a hard jump done from one version to another. Whereas in language, you have some room to tackle the same situation through some different pattern without literally jumping the language version, unless it's a pretty hard version like Python 2 to Python 3 certainly would be a different thing. But in the minor versions of Python, it won't really matter, right? So this is where you can keep on absorbing new changes at relatively easy pace, and this is where you won't have changes frequently introduced to your infrastructure unless the upstream API is changing, or there is some deprecation happening because of some critical vulnerability, or let's say some hard fix or bug fixes coming because of some CVEs or any gaps, right? So with respect to the question, the dynamic nature of cloud environments, how does it impact IAC and Python? So it should not really impact much. It's just that the new resources that are going to be added, you will be able to leverage them. Even if upstream APIs are getting changed, it's all API interaction, right? So we need to understand that APIs are just exchanging data in some specific format, and being a programming language, it is more flexible. It is more flexible to incorporate such data exchanges. So it's more flexibility that you should be getting towards. So and there will be less changes that you will need to do. So anyway, like that should be a seamless process.
So as they say, change is always good, right? You have more features, you have a better productivity in terms of rolling things out. Again, Anmol, I think we have used up the time we have. I really enjoyed your sharing in that sense. I just want to remind all our attendees that we will be publishing this on the official YouTube channel for Cybian. So you can actually rewatch and replay this again. Please do not forget to download the handout that Anmol has actually diligently prepared for us. I think that will be a good reference into today's workshop. I really want to thank you for that. Anmol, again, thank you for your time, for joining us on today. Really, really appreciate it. And I thoroughly enjoy you sharing all the new features of Plumber. Actually, I would love to actually get my hands on and try that out again soon. Right. Just a quick reminder to everybody, we will have a session which is coming up next. It's the panel discussion. Do join us on the hour. For this, we will have the topic of human-robot collaboration on the future of work. So we have Yan will be chairing it, and we will have 3 guest speakers or panel speakers who will be actually debating or discussing this. Do join us for that session, and I wish you all the best for the upcoming work that you have. Thank you, Anmol, for joining us again. Really appreciate it. Thank you, guys.
My pleasure. Bye.
Bye. Thank you.